Welcome back to visualpatterns.org. This is visual pattern number 256. This is a number talk to get your students talking about what they see algebraically given variables x and y, so they can use a table to generate an equation. And today we're even going to look at the graph that shows the equation that we come up with. So let's get started, shall we? Here we have the x's, the iterations 1, 2, and 3. 1, 2, 3. Here we have the outputs, the y values. We have this number of purple squares, this number, and this number. You can see in the first iteration there are 4. Then in the second iteration, we can see there are 2, 4, 6, and then 7 total purple squares. In the third iteration, I can see there's like 3 here, 3 here, 3 here. That's 9 plus 1 more, so that gives me 10 in the third iteration. And thinking that's a pattern, I can go back and see. I'm going to make this a little easier to see. There's a group of 3, 3, and 3 purple squares. Here, there's a group of 2, 2, and 2. Here, there's 1, 1, and 1. And then every time, there's this extra square. So that seems to be a growing pattern where there's like 3 groups of something growing every time. And then in the fourth iteration, it's possible in the fourth iteration that there would be like 4 vertical blocks, then 2 groups of 4, and then 1 more extra one. So that would be 4 plus 4 plus 4 plus 1. That's 13. Now, there are many ways to go now that we kind of see the pattern here. One, if you recall, is looking at this vertical pattern. I see a skip counting, 4, 7, 10, 13. That means the y value is increasing by 3 every time the x, the iteration, goes up by 1. So we've learned what that represents, and we'll see it again here in a moment. But I think more importantly, we can compare the iteration number to the output by way of the fact there's a connection between iteration 1, there are 3 1s. Iteration 2, there are 3 2s. Iteration 3, there are 3 3s. And iteration 4, there would be 3 4s. That's repeating, that's a pattern. 1, 2, 3, and 4 represent the x value. So the equation has something to do with 3x. But I can also see there was always this one more constant square sitting out to the side. That's represented by the plus 1. I can check my work and say, well, what is 3 times 1 plus 1? It's 4. What is 3 times 2 plus 1? It's 7. 3 times 3 is 9 plus 1, and so on. So in the 15th iteration, you can picture 15 3 times plus 1. So it's 15, 30, 45, it's 46. So the equation is y equals 3x plus 1. Now let's compare that to the graph. And notice in the graph that there is a slope. The line goes up and up and up and up. It goes up 3 on the y-axis every time it goes over 1 on the x-axis. So up 3 over 1. It's like building a staircase. And also, the cool thing is this idea of plus 1, well, that comes out in the fact that if I don't move on the x-axis at all, if I plug in 0 for x, 3 times 0 plus 1 is 1. And this point 0 comma 1, that comes out as the y-intercept in the equation, because there is this parent equation called y equals mx plus b, where the b value is where the line crosses the y-intercept because x is 0. And the m, that stands for the slope. We'll get more and more into this as time goes on, but these are all important aspects of seeing the visual pattern, seeing the table grow linearly, and then making the equation. Thanks very much. I hope you have a great afternoon, and let me know if you have any questions about this pattern. Thanks. Thank you very much. I hope you learned a lot, and let me know if you have any questions. Please like and follow for more. Thank you.